करे भाई chepo twarga. Shall we start with the class? Yeah, okay, no problem. Yeah, okay. So I think in last class we completed our part of angular momentum and its conservation. Yeah, okay, no problem. Yeah, in last class we were talking about angular momentum, and we also studied about conservation of angular momentum, and we also completed today we have to start with our next part. We have to start with our part related with rolling motion. You can write rolling motion. So let's start with our part rolling motion. Today we will talk about rolling motion. Today we will talk about rolling motion. Today we will talk about rolling motion. So many times previously question has been asked from here. So again one of the important topic. Yeah, rolling motion. Rolling motion. So any idea what is rolling motion? We studied translational motion, we studied rotational motion. Now we are going to talk about new type of motion, which is rolling motion. So Remant is saying rolling motion means linear plus rotation. Okay, no problem. Yeah, okay. So anyone else, any idea about rolling motion? Rotational plus translational. Okay, Sam. Yeah, correct. No problem. Remant, your answer also correct. So combination of translational and rotational motion is known as rolling motion. Yeah, rolling motion is actually combination of translational and rotational motion. Yeah. Many times when you see the body will translate also and body will rotate also. So when any body translate also and when any body rotate also at the same time, we call it as rolling motion. You can write this point, yeah. You can write it is combination of translational, yeah, Srikar correct, no problem. Yeah, it is combination of translational and rotational motion. It is combination of translational and rotational motion. It is combination of translational and rotational motion. So always remember, when body translate also and at the same time body rotate also, then we call that combination of translational and rotational motion we call as rolling motion. For example, if you look at wheels of the car, or if you look at wheels of bike, scooty or cycle, those wheels rotate also and at the same time they translate also. So we say wheels of the car are doing rolling motion because they have rotational motion also, about center they rotate also and their center move forward also. So whenever body has translational motion also and body has rotational motion also, that combination of translational and rotational motion we call as rolling motion. For example, this pen is there, yeah. When I keep this pen on my hand like this and I do like this, you see, now pen is translating also. Pen is going from one corner of hand to the other corner of the hand. So pen is doing translational motion also and at the same time pen is rotating also. So this sum of this combination of translational and rotational motion we call as rolling motion. Is it okay? Is it okay? Is it okay? Meaning of rolling motion okay? Means combination of translational and rotational motion. Come on, tell me, is it okay, Saray? Then we will move further. Slowly we will talk. Bol do bhai. So when body will do translational motion also, at the same time body will do rotational motion also, that combination of translational and rotational motion we call as rolling motion. Is it okay? No problem. Simple, sir. If you look at example, best example are the wheels. Wheels rotate also, and at the same time they translate also. So when we combine rotational and translational motion, we call it as rolling motion. No problem, no problem. Now you can write condition for rolling. Now we will talk about little detail about rolling motion, from where questions will come. Yeah, okay, no problem. Yeah, you can write condition for rolling. Condition for rolling. So just see here how that condition will come. Be focused, develop understanding. How we'll be talking. Just see here. Yeah, okay, no problem. Yeah, we are going to talk about condition for rolling. Condition for rolling, okay, and see how the things will happen. And for getting condition, we will again talk in the similar manner. We will say, sir, rolling is combination of translational and rotational motion. So just see, this is how things happen. Just see. Okay, no problem. Yeah. Okay. So understand how to get condition for rolling. For example, assume we have, for example, be focused, then only you'll get idea what I'm trying to tell. For example, assume we have a body. This body can be a ring, this body can be a disc, this body can be a hollow sphere, this body can be a solid sphere. No problem. Yeah. So, for example, assume this body is there. I'm saying, sir, right now this sphere, or ring or disc. Now, right now, this sphere or ring or disc is doing translational motion. Always remember, rolling will not come directly. First, translational motion will be there, then rotational motion will be there. When you superimpose both of them, when you add both of them, we will get combined rotational and translational motion. And that combined rotational and translational motion is known as rolling motion. So, for example, assume right now, this sphere or ring or disc is doing pure translational motion. Right now, this sphere or ring or disc is in pure translational motion. It is in pure translation. It is only doing translation. So, if your body is only doing translation, that means every point will have same velocity. For example, if I say velocity of its center to be VCM, this point will also have same velocity VCM. 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 This is the meaning of pure translational motion. Whenever any body do pure translational motion, every point, it is not rotating na baba, so every point will travel same distance in same time. So every point will have same velocity. So that's why I'm saying if velocity of center is VCM, then velocity of every point present on the body will be same velocity VCM. And this is our pure translational motion. And right now body will have translational kinetic energy. Right now if someone says, yeah, okay, no problem. We will talk about it. Yeah, okay. Right now we will say body will have translation. Since body is doing pure translation, that's why body will have only translational kinetic energy. And translational kinetic energy, you know, half m into v square. And what is v of every point? VCM. So half m into VCM square. No problem. Yeah. This is pure translational motion. No problem. Yeah, okay. Now we are going to talk about, sir, if the same body is doing pure rotational motion, then what will happen? If the same body is now body is only translating. Now second situation, body is only rotating. Rotating means rotating about center with some angular velocity omega. Right now body is doing pure translation. Now body is going to do pure rotation. When you combine both of them, then you will get a rolling motion. Yeah. So right now body was doing pure translation. Pure translation means body will rotate about its center. Center will be our axis. Center will be fixed. About center body will rotate with some angular velocity omega. Now if body will rotate with angular velocity omega, you know every point on the body will have tangential velocity. V will be equal to omega r. Now this point will have velocity V equal to omega r. This point will also have velocity tangential. It is rotating about center like this. So this point will have velocity omega r. This point will have velocity backward omega r. This point will again have velocity tangential omega r. And this right now this body will have rotational kinetic energy. Rotational kinetic energy, you know, if its moment of inertia about center is I, rotational kinetic energy will come half I into omega square. This is pure translation, this is pure rotation. When you add both of them, you will get rolling motion. First you can draw these two diagrams. Come on. So first situation, body was doing only translational motion. Jameer, we will get that condition. Second situation, body is doing only rotational motion. So pure translation, pure rotation. Okay, correct. Once you complete the diagram, you can say done, sir. First body is doing only translation, second body is doing only rotation. Yeah, and once I will say done, sir, you start saying done, sir. No problem, no problem. Yeah. Now, sir, body was doing, first body was doing pure translation, then body was doing pure rotation, and we know, sir, if you combine both of them, we will get our rolling motion. Rolling motion is combination of, rolling motion is superimposition of pure translation and pure rotational motion. Yeah, okay, no problem. Now, dhyan do. Now, if you add these two figures, if you superimpose these two figures, right now here velocity of the center will be 0. Here center will, because center we are taking as axis of rotation. Now, if you superimpose these two figures, or if you simply add these two figures, you will get your rolling motion. If you add it, this is the meaning of rolling motion, Baba. It is combination of pure translation and pure rotation. So if you combine pure translation and pure rotation, now body will do rolling motion. Now if that means if now body will do rolling motion, sir. Now if you look at, sir, if the body will do rolling motion, that means if you combine both of them, you will realize that now topmost point velocity will be, you see here VCM, here omega r. So topmost point velocity will become VCM plus omega r. No problem. Yeah. Now this horizontal point velocity will become, due to translation, VCM, and due to rotation, I am going to add these two. Everywhere I will add these velocities. So if you add at the top, both are in the same direction. So that's why it became VCM plus omega r. If you look at horizontal, VCM like this, omega r downward. So omega r will be like this. If you look at the bottom, both are in opposite direction. VCM was forward, omega r is backward. That means bottommost point velocity will become VCM minus omega r. Yeah. And if you look at again horizontal point, now again if you look at horizontal point, now one VCM will come forward and omega r will come upward like this. And velocity of the center will be same as our VCM. Because their VCM, here velocity of the center is 0. So if you combine 0 plus VCM, you will have VCM. And now body will have total kinetic energy. Total kinetic energy means kinetic energy translation plus kinetic energy rotation. That means it will be, sir, now half m VCM square plus half I omega square. Is it okay? This figure which you are seeing here is your combined, this figure which you are seeing here is combined rotational and translational motion. Rotation and translational motion. Translational motion. And rolling is a special case of this. For pure rolling, we are taking center as axis, so VCM will be 0. Once you can draw this diagram, then I will talk about condition, main condition for rolling. Till now I was telling you meaning of rolling motion. Yeah, okay, no problem, no problem. Yeah. Once completed, you can say done, sir. हाँ, no problem, no problem. Now ध्यान दो, be focused. Main part. Now our diagram is this. Yeah, these are not required. Now our diagram, main diagram is our rolling motion. Now we are going to talk with the help of this diagram. ध्यान दो. Be focused. Then only you'll be able to develop understanding. Then only you'll be able to solve good questions which can be asked from rolling motion. So थोड़ा ध्यान देना. Be focused. Just see here. Yeah. Okay, no problem. Yeah. Okay. Now always remember for pure rolling or for rolling, always remember we have a condition for rolling. For rolling, this velocity of center of mass must be equal to omega r. Condition for rolling, always remember your VCM should be equal to omega r. This is the condition for rolling that we get. For rolling, VCM should be equal to omega r. So always remember, if anyone asks you what is condition for rolling of a body on the ground, condition for rolling of the body on the ground is VCM will be equal to omega r. For rolling, VCM will be equal to omega r. That means if you put VCM equal to omega r in the figure, see how change will happen. Now someone says, sir, for rolling I know VCM will be equal to omega r. That means if VCM will become equal to omega r, can you tell me what will be velocity of the topmost point now? For rolling, not always VCM here will not be equal to omega r. Your VCM will be equal to omega r only when body is doing rolling motion. For rolling, VCM equal to omega r. So here if you put omega r equal to VCM, so you'll get VCM plus VCM. Topmost point velocity will become 2 VCM. Topmost point velocity will become 2 VCM. So always remember, whenever any body rolls, velocity of the topmost point will be double of velocity of center of mass. Yeah. So you can say 2 VCM also, or you can say 2 omega r also. No problem. Yeah. Already we know velocity of center, sir. Velocity of center we are already knowing, sir. Velocity of center will be VCM. Achha, can you tell me what will be velocity of the bottommost point? What will be velocity of bottommost point? Here VCM minus omega r. So if you put omega r equal to VCM, here you will get VCM minus VCM. So velocity of the bottom will become bottom, or we say velocity of the contact, that will become 0. Are VCM minus omega r na baba. For rolling, omega r and VCM both are equal. So if you put omega r here, VCM will get cancelled. Velocity of the bottom will become 0. Now if anyone asks you velocity of the horizontal points, these are also special points which are asked. If anyone asks you, sir, what is the velocity of the horizontal points present on the body? Yeah, Zamir, that is okay, that is correct, no problem. From there only we get, yeah, okay. Someone asked me, sir, velocity of horizontal point will be how much? Now you can see, one VCM was already there, omega r was downward, this omega r is also now equal to VCM. That means horizontal point velocity will become root 2 VCM. Resultant of this translational VCM, rotational VCM. So resultant of this will become root 2 VCM. Similarly, if you look at this horizontal also, VCM like this, omega r like this. Now this omega r is also equal to VCM. So now VCM, you'll get resultant root 2 VCM. So velocity of both horizontal, these are two vertical points. Top velocity 2 VCM, bottom velocity 0, center velocity VCM, horizontal velocity of the horizontal points will become root 2 VCM. So these are the main things which are asked here. Yeah, okay, no problem. Where omega are down, where here omega r is down, so VCM resultant will come perpendicular na baba, root 2 VCM. Is it okay? Is it okay? बोल दो भाई. So finally what we learned here, just see here, yeah, okay, no problem. Final conclusion, what you have to keep in your mind, just see here, yeah, okay, no problem. First thing, your VCM will be equal to omega r. First point. Second point, what is the velocity of the topmost point? Bolo, what will the velocity of topmost point? When the body is rolling, what is the velocity of topmost point? एक बार बताओ तवर्गा. Second important point, they will ask you what is the velocity of the topmost point. What is the velocity of topmost point? Jaldi bata do. Velocity of topmost point will be double of center. That will be 2 VCM. Or you can say 2 omega r. No problem. Yeah. Third point which is asked here, what is the velocity of 2 horizontal points? Horizontal points ka jaldi bata do velocity. What is the velocity of 2 horizontal points? What is the velocity of 2 horizontal points on the body? What is the velocity of 2 horizontal points on the body? Velocity of the horizontal points on the body will come, sir, root 2 VCM. Or you can say, sir, root 2 omega r. And fourth point is velocity of the bottom or velocity of the contact. Velocity of the bottom or contact will always come 0. Velocity of the bottom or contact will always come 0. Okay, no problem. Yeah. That means always remember in rolling motion, sir, first condition for rolling motion, sir, VCM will be equal to omega r. Condition for rolling, sir, VCM equal to omega r, first point. Second point, velocity of the top will be 2 VCM. Velocity of top will be double of center. So velocity of top will be 2 VCM. So velocity of horizontal will be root 2 VCM. And velocity of the contact will be sunna. Is it okay? Is it okay? All these diagrams, everything I told you just to tell you this thing. VCM equal to omega r, velocity of top is 2 VCM, velocity of horizontal is root 2 VCM, velocity of the bottom is 0. Yeah, okay, no problem. I will give you one question. Come on. I will give you one question. I will give you one question. You write. A sphere of radius 2 meter, a sphere of radius 2 meter, a sphere of radius 2 meter is rolling with angular velocity of, a sphere of radius 2 meter is rolling with angular velocity of 5 radian per second. A sphere of radius 2 meter is rolling with angular velocity of 5 radian per second. Find all answers you will tell together. Find first VCM, second velocity of the top, third velocity of the horizontal, fourth velocity of the contact. If anyone asks you VCM, you already know rolling means VCM will be equal to omega r. So first one will come, sir, omega given, r given. So we already know, sir, VCM will be omega r. So this will be coming as 10 meter per second. Yeah. Hanudeep, all answers correct. Very good. Yeah. Okay. Amrut, all answers correct. Vedasri, second answer will come. We already know, so velocity of top will be double of VCM, 2 VCM. So 2 into 10, it will come, sir, 20 meter per second. Yeah. Okay. No problem. Yeah. Sir, velocity of horizontal, we already know, sir, root 2 VCM. That means root 2 into VCM is omega r, which we already calculated 10. So it will come as 10 root 2 meter per second. And velocity of contact, no need to calculate, it will come 0. Yeah, okay, no problem. Yeah, okay. So this is how we talk about basic thing, how to find velocity of different points present on the body in the case of rolling motion. Now dhyan do, be focused, just see here. These are the questions which has been already asked in the NEET exam. These are the things which are already asked in the NEET exam. Again, they can ask important situation, no problem. But one more thing is given in NCERT. Dhyan do, be focused, yeah, okay. Okay, no problem, yeah. Yeah, one more. Yeah, okay, no problem. One more observation I will tell you. Dhyan do, be focused, develop understanding. Then you will be able to get what I'm trying to tell. Just see here. Yeah, okay. One more observation I will tell you. You will realize this is given in NCERT also. But not asked in the NEET. But again, they can ask this situation. So, thoda dhyan dena, be focused. Then only you'll be able to understand what I'm trying to tell. Yeah. If you observe carefully now, you will realize that as the distance of the point from bottom is increasing. For example, if you see topmost point distance from bottom is double of center. If center distance from bottom is r, topmost point distance will be 2r now. That's why its velocity is coming to VCM. Arey Baba, you have to develop understanding. For center distance is r, for top distance is 2r. That's why this velocity is coming to VCM. For horizontal, this distance will be root 2r. For horizontal, if you see, this is r, this is r. For horizontal, from bottom distance will become root 2r. That's why its velocity is becoming root 2 VCM. Centers at bottom distance is 0. That's why velocity of the bottom is becoming 0. Topmost distance from bottom is double. So that's why velocity is double of center. So center is r, topmost is 2r. Similarly, if you see horizontal points, so distance is root 2r. That's why velocity is becoming root 2 VCM. This is the observation I'm trying to tell. So always remember, as the distance of point from the bottom increases. For example, tomorrow someone give you 2 points. He gave point A, he gave point B, and he gave point C. They can ask you tomorrow, out of A, B, and C, which point, if this body is rolling, they will ask you, out of A, B, and C, which point will have more velocity? Can you tell me which point will have more velocity when body will roll? Which point will have more velocity? Which point will have least velocity? Always remember, as distance from bottom increases, speed of the point will also increase. Speed will also increase. So always remember, this point C will have, distance of C is maximum na baba. Then you have distance of A na, you have minimum distance of B. So that's why we'll say, sir, VC will be maximum. Then we have VA, then we will have VB. Same thing we can write for their acceleration also. If you differentiate velocity, you'll get acceleration. AC will be more than AA, will be more than AB. And always remember, okay, so as the distance from bottom will increase, your velocity will increase. Bol do bhai, bol do, we'll move further. Is it okay? And this bottommost point we call as instantaneous axis of rotation. Just I'm giving you information. Just keep in your mind that this bottommost point is also known as instantaneous axis of rotation. This is not in your NEET syllabus, but given in NCERT. They will not ask you, but just I am giving you idea. Because if you know axis, you can write velocity of every point now v equal to omega r. And if you know the distance from bottom, you can write the velocity now v equal to omega. If you know distance from axis, you can write now v equal to omega r. If distance from axis is more, v will be more na baba. So that is what you are writing. As the distance from bottom increases, speed also increases. And actually this is your instantaneous. At this instant, this is axis of rotation. Bolo, 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 targa. Just information I gave you, bottom is your instantaneous axis of rotation. That much is not required, but okay. बोलो बोलो हो गया. Once completed, you can say done, sir. We will start with our next part here. जल्दी भाई. So as the distance from bottom increases, speed increases. So bottommost point is also known as instantaneous axis of rotation. And you know, if you know axis of rotation, speed of any point you can write v equal to omega r. So if r is more, v will be more. So that's why more distance, more speed. No problem, no problem. Now we'll move further. We will talk about, you write kinetic energy in rolling. Kinetic energy in rolling. Kinetic energy in rolling. Kinetic energy in rolling. And actually question in NEET, most of the question, yeah, okay, no problem. Jabir, yeah, correct, no problem. Huh? So we are going to talk about kinetic energy which body have in rolling. And you know, in rolling, both motions are there, na translation also there, rotation also there. That's why body will have translational kinetic energy also. Body will have rotational kinetic energy also. And if you add them, you will have total kinetic energy. And from here they will ask you find ratio of kinetic energy, or they will ask you find percentage of rotational kinetic energy, or percentage of translational kinetic energy, or fraction of kinetic energy. So they are be focus, one of the most important part. If question will come, 90% chance question will come from kinetic energy during rolling. So always remember, you already know. Sir, already we know, sir, in rolling, body will have translational kinetic energy. Body will also have rotational kinetic energy. And when you add both of them, you will also get, sir, total kinetic energy. Total kinetic energy means kinetic energy translation plus kinetic energy rotation. No problem. Yeah. Translational kinetic energy already we know, sir. Half mv square. Actually, it is VCM square. But velocity of center I am taking as v. So that's why I'm writing translational kinetic energy as half mv square. Rotational kinetic energy already know, half I omega square. Total kinetic energy you already know, sir. Total kinetic energy will become, sir, translation plus rotation. That is half mv square plus rotation, sir, half I omega square. Now in the NEET they generally ask ratio of these energies or fraction of these energies. So whenever anyone asks you ratio of this energy, ratio we can find, sir. And we can simplify this ratio because we know translation is okay, sir, half mv square. Rotation we can write, sir, half I you can write in the terms of radius of gyration. At a moment of inertia you can write in the terms of radius of gyration. I will be mk square, and omega square you can write as v square by r square, because just now we studied for rolling v will be equal to omega r. So omega will be equal to v by r. So omega square will become, sir, v square by r square. Is to total. Totals are half mv square plus half I we know, sir, mk square. Omega square will become, sir, v square by r square. That means from here, if you simplify the ratio, this will become half mv square is to. Here you can again take half mv square separate, so that in ratio it will get cancelled. Here you will get k square by r square is 2. Here also you can take half mv square common. Here 1 will be left and here left will be your k square by r square. Now if you find this ratio will give you your answer. This ratio will come. This ratio is asked. That's why we are talking about. Yeah. Half mv square, half mv square, half mv square cancel. You'll get the ratio of translational kinetic energy is to rotational kinetic energy is to total kinetic energy. 1 plus k square by r square. This is the ratio we were searching for. This ratio is asked. First you can write this, come on. Yeah. Total no need to calculate. Total at the end you can add also. No problem. Yeah. Translation plus rotation will give us total. So always keep this ratio in your mind. If you feel problem, you can derive it. Yeah, Jamir, correct. For translation 1, for rotation k square by r square, and for total 1 plus k square by r square. This is the ratio of 3 kinetic energies which body will have during rolling. Translation is to rotation is to total. Is it okay? So ratio of kinetic energy translation is to rotation is to total will be 1 is to k square by r square is to 1 plus k square by r square. 1 is to k square. Come on, everyone will say, what is the ratio of kinetic energy translation, rotation and total during rolling? Are bolo. 1 is to k square by r square is to 1 plus k square by r square. And no sound is coming. Come on, say, what is the ratio of 3 kinetic energy in the rolling? 1 is to k square by r square is to 1 plus k square by r square. 1 is to k square by r square is to 1 plus k square by r square. Is it okay? एक बार बोल दो भाई. What happened? Everyone went in silence. क्या हो गया? न्यूक्लियर बॉम्ब गिर गया क्या घर पे? Israel Hamas war, nuclear bomb directed to your house. हाँ, 1 is to k square by r square is to 1 plus k square by r square. Done, sir. Understood, sir. No problem. Translational is to rotational is to total will be 1 is to k square by r square is to 1 plus k square by r square. Diwali also coming. No problem. Yeah. 1 is to k square by r square is to 1 plus k square by r square. Now ध्यान दो. Be focused. Yeah. Okay. No problem. Yeah. हाँ, okay. बहुत बढ़िया पुरुषोत्तम. No problem. Gyarashwari, very good. Yeah. Okay. No problem. Yeah. Okay. हाँ. अच्छा, no problem, Manas. No problem. Yeah. Okay. Now ध्यान दो. Be focused. Yeah. Okay. अच्छा. What is this k here? Sir, 1 is to k square by r square is to 1 plus k square by r square. What is k here? What is k? Sir, 1 is to k square by r square is to 1 plus k square by r square. What is k here? क्या है k बताओ? What is k? Radius of gyration. Now ध्यान दो. Be focused. Just here. Yeah. Okay. ध्यान दो. Be focused. One thing I will tell you which will make your calculation fast. Generally what happen? ध्यान दो. In order to use this ratio now, first you have to calculate radius of gyration, then you have to put here, then you have to solve. That will make your calculation lengthy. Always remember this k square by r square is a special number. No need to calculate while finding ratio now. No need to calculate k first, then I will put there, sir, then I will get answer. It will become lengthy. Actually, k square by r square is property of rigid body. K square by r square is a number whose value you already know, you have already studied. ध्यान दो, what is actually K? Sir, in the question, does I have to calculate radius of gyration? Then I have to put there to get the ratio. No need to calculate directly. You can write value of K square by R square because you already know. ध्यान दो, what is K square by R square? Just see here. Yeah, okay. For example, always remember for ring you know moment of inertia na. For ring, moment of inertia about geometrical axis is 1 mr square. We generally say mr square, but actually we say its value is 1 mr square. So for ring, K square by R square will come 1. Actually, K square by R square is coefficient of mr square in the value of moment of inertia. For example, yeah, Jamir, very good. Yeah, for example, someone says, sir, I have a disk. If you have a disk, for disk moment of inertia is 1 by 2 mr square now. So for disk, K square by R square will come simply 1 by 2. For hollow sphere, come on, tell me, for hollow sphere, everyone tell me, for hollow sphere, what is K square by R square? For hollow sphere, so for hollow sphere, moment of inertia is 2 by 3 mr square now. So what is coefficient of mr square? 2 by 3. So it will come 2 by 3. And for hollow sphere, moment of inertia is 2 by 3 mr square. Baba, moment of inertia ही नहीं याद है तो कैसे निकालोगे K square by R square? K square by R square will come 2 by 3. Now they can ask you for solid sphere. बताओ for solid sphere. Solid sphere के लिए बताओ. Solid sphere moment of inertia is 2 by 5 mr square. So for solid sphere, K square by R square will come 2 by 5. No need to calculate K. Directly you will put the value because you already studied moment of inertia of different bodies. Ring also means hollow cylinder. Tomorrow they can give you cylinder, yeah, hollow cylinder. Disc also means solid cylinder. So be careful, no need to calculate K square by R square. Directly you can get the answer. Directly put the value of K square by R square. So what is K square by R square? You can write this point also, come on. You can write this so that during revision it will be helpful for you. You write. Actually K square by R square. Actually K square by R square. Actually K square by R square. Actually K square by R square is coefficient of mr square. Actually K square by R square is coefficient of mr square in the value of I of the body. In the value of I of the body. Actually K square by R square is coefficient of mr square in the value of K of the body, in the value of I of the body. So come on, tell me, for ring what will be K square by R square? What is the value for ring? For ring what is K square by R square? तोरगा बोलो. For ring, for disc, for hollow sphere, for solid sphere. जल्दी बताओ. Of course, that is the axis about which body can roll. Yeah, 1. For ring it will be 1, sir. For disc तोरगा. For disc, jaldi, for disc. Are moment of inertia of disc is 1 by 2 mr square na. So for disc K square by R square will come 1 by 2. 1 by 2. For hollow sphere, moment of inertia is 2 by 3 mr square na, sir. So for hollow sphere, K square by R square will come 2 by 3. 2 by 3. For solid sphere, sir, moment of inertia is 2 by 5 mr square na. So K square by R square for solid sphere will come 2 by 5. 2 by 5 for solid sphere. Yeah, okay, no problem. All these values will be required when you calculate ratio. Now one more thing, one last thing, then we'll start with numerical. Just see here, one more thing, yeah. Okay, no problem. We'll use all these values. Dhyan do, be focused, just see here, yeah, okay. Okay, Now, since you are having ratio now, questions are also asked about fraction. Tomorrow they can ask you, dhyan do, be focused, yeah. The way you calculated mole fraction now, when you are calculating mole fraction of A, you wrote moles of A by total moles. In the similar manner we say, They will ask you, find fraction of kinetic energy of the body which is translational. They will say, a body is rolling. Find fraction of kinetic energy of the body which is translational. So when you calculated mole fraction, when you calculated mole fraction of A, you said moles of A by total moles in the similar manner. Now we are calculating fraction of kinetic energy translation. Means kinetic energy translation by kinetic energy total. Translation you already know. Translation you already know 1. Total you already know. Total you already know 1 plus k square by r square. This is how we calculate fraction of kinetic energy translation. And tomorrow if anyone asks you percentage, you can multiply fraction with percentage, you will get your percentage of kinetic energy which is translational. Tomorrow they can ask you fraction of kinetic energy. They can also ask you fraction of kinetic energy which is rotational. So fraction of kinetic energy rotational means kinetic energy rotational by kinetic energy total. Rotational you already know, sir, k square by r square. Total we already know, sir, 1 plus k square by r square. If anyone asks you percentage, multiply with 100. Multiply fraction with 100, you will get percentage of kinetic energy. Bol do bhai, bol do. No need to remember this formula. You must know the meaning of fraction. If I have 2 rupees coin and 10 rupees note, if anyone asks me what is the fraction of money that I have in the form of coin, so coin by total, coin is 2, total is 12, same thing you are doing. And if you know fraction, multiply with 100, you will get percentage also. No need to remember, you need to know meaning of fraction. So fraction of kinetic energy translation means total में कितना translation है. And fraction of kinetic energy translation means मोत्तम out of मोत्तम entire is translational. That means translational by total. So fraction of kinetic energy rotational. So out of mottam, how much is rotational? So rotational by total. And if you know fraction, multiply with 100, you will get percentage also. Is it okay? You can do that also, Pawan. No problem. You can do. No problem. Yeah. Okay. बहुत बढ़िया, बहुत बढ़िया. We'll start with one question. Come on. You right? हाँ. Same, Baba. That is fraction of mole. This is fraction of energy. Fraction is same. Yeah. Okay. No problem. हाँ. You can write a disc rolls. You write a disc rolls. A disc rolls. Then find a disc rolls. Then find a disc rolls. Then find ratio of. Then find ratio of is translational and rotational kinetic energy. If a disc rolls, find ratio of its translational and rotational kinetic energy. Total not given, so no need to write total. 2:1. Raman, very good. Yeah. Find, if a disc rolls, find ratio of its translational and rotational kinetic energy. First, we will always write the formula. So translational 1, rotational k square by r square. Sir, you are talking about disc. So now we will put the value of k square by r square. 2:1 will come. Yeah, very good. Yeah. For disc we will put, sir, 1:2. For disc just now we stated k square by r square will be, sir, 1/2. So if you simplify, this ratio will come 2:1. Is it okay? Is it okay? Do the next question. Come on, do the next question. Chalo. Torga. You write. You write. If a solid sphere rolls, if nothing is given, that means sphere will be always solid. When this question came in the NEET exam, they did not mention which sphere they are talking. Yeah, and this type of mistake they do. So whenever sphere type is not mentioned, you have to always take that sphere as solid. Right? When a solid is, a solid sphere rolls, Then find a solid sphere rolls. Then find fraction of its kinetic energy. If a solid sphere rolls, then find fraction of its kinetic energy. Then find fraction of its kinetic energy, which is rotational. They are asking you, if a solid sphere rolls, find fraction of kinetic energy, which is rotational. Fraction of kinetic energy rotational means rotational by total. Now you will put, first you will write this formula, then you will put rotational by total. Rotational we know, sir, k square by r square. Total we know, sir, 1 plus k square by r square. Now values put at the solid sphere 2 by 5 by 1 plus 2 by 5. 2 by 7 will come. Yeah. Ganesh very good, Pawan very good, Gautami very good, Hanudeep very good, Kalangiri very good, Kalyan very good, Srikar very good. Our answer will be coming as, if you simplify this will become 2 by 5 by 7 by 5. 5 will get cancelled, you will get answer 2 by 7. Do the next question, come on. Do the next question, come on. Yeah, do the next question. Very easily we can find. 2 by 7 will come, yeah, okay. You write, if a ring rolls, find percentage of its kinetic energy, which is translational. If a ring rolls, find percentage of its kinetic energy, which is translational. So I'll simply say percentage of kinetic energy. Translational means translational by total into 100. This is the meaning of percentage of kinetic energy. 50% will come. बहुत बढ़िया. Very good. Fraction will come half. Multiply fraction with 100. You will get percentage 50%. बहुत बढ़िया. Translation we already know, sir, 1. Total we already know, sir, 1 plus k square by r square. This is fraction. Fraction into 100 will give you percentage. And for ring we already know, sir, k square by r square will be 1. Into 100, this will give us 50%. Is it okay? So this is how we have talked about, yeah. And more situations from here also, more questions we'll study from here in our next class. Is it okay? For today we will end our class here only. More situations from here we'll be talking in our next class. For today we'll be ending our class here only. I have to go to other campus. So for today, bye. Take care. Study well. अच्छे से पढ़ाई करो. Study with responsibility. Now date has been decided. 5th May target loaded. 5th May target loaded. You have to hit the target. And for that hitting target, you must have to prepare in the best possible manner. So अच्छे से पढ़ाई करो. More situations we'll talk in next class. For today we'll end here only. Tata, bye bye.